you. Welcome back to Data Science Analytics track, where everything is going perfectly fine. Thank you very much. And we have Sangarshanan speaking next about interactive map making with Python. Sangarshanan describes himself as a professional meme connoisseur and part-time developer, or a professional developer and part-time meme connoisseur. You decide. Over to you, please.
Hey, thank you for that lovely introduction. Welcome everyone. We are doing fine now. Welcome to my talk. It's interactive map making with Python. Welcome everyone to PyCon Australia. Yes, that was a joke. Thank you very much. So today we're going to talk about making interactive maps with Python. And my name is Sangarshanan, and I'm going to talk to you about it. So I'm going to begin by proclaiming my love for pandas and data frames. So whenever I want to work with data, I immediately go to pandas, and a lot of us do, and it's for a reason. Pandas is amazing. It gives you an amazing interface for working with data, and you can do a lot of cool and amazing things with it. Merges, plotting, and all the kind of stuff. But something weird happened. I encountered something for the first time. Location in my data, which means they had latitudes and longitudes. So here's what the data looks like, right? I'm reading a CSV file, easy as that, and it has latitudes and longitudes, which means this is a whole new realm for us, a data with location component. So a data with location component. A location can be represented as geometries, right? And what is a geometry? A geometry can be either a point, which is latitude and longitude, or a polygon, which is a list of points. So here I'm grossly oversimplifying the concept of geometries, and Euclid would be really angry with me right now. But yeah, for the sake of this talk, let's assume that we have points and polygons and different types of polygons essentially. We also have line strings, which are polygons that don't complete. We have multi-polygons, which is a fancy plural word for polygons, and we also have circles. So now enter Geopandas. Geopandas will enable you to work in the realm of data frames without leaving, it'll enable you to work with location data without leaving the realm of data frames. So here are some of the cool things that Geopandas has to offer. One is the one which I discussed right now. It provides an interface with data frames to work with geographic data. The next one is it allows you to read and write GIS formats, really popular formats like shape files, GeoJSON files, KML files, using another library called Fiona. It also helps you perform spatial operations like you perform on pandas, on normal data. You can perform spatial operations on geographic data, like you can perform geospatial merges between two polygons, you can perform joins, and you can perform overlays. And all this is possible using another open source package called Shapely. So it's all this intricately woven open source ecosystem tying together. And also, the crux of our talk, we can plot them on a map, and Geopandas uses Matplotlib and Descartes to help you do that. And also there's a whole lot of other things you can do with Geopandas, not just this. And if you want to know more, you have to definitely check out this tutorial by the maintainer of Geopandas. So now going back to our original data frame, we're going to convert it into a Geodata frame. So to do that, we're going to be importing Geopandas, of course, and then we're going to take the data frame and we're going to pass it to geopandas.geodataframe, and then we're going to pass an argument for geometry. So geometry specifies which columns to consider to create that geometry. So here our geometry is a point because it's latitude and longitude. So we create that point from those two columns by using geopandas.points from xy, which takes in the lat long columns and creates a geodata frame for you. And after that, we have something weird, setting the projection .crs. What is that? So CRS refers to the coordinate reference system. So these are the different ways we can project the world, which is a geoid, onto a plane that we can understand and interpret. So here we use ESPG, 4326, which is a standard projection which is used in satellite navigation systems or GPS. So coordinate reference systems actually give spatial meaning to latitudes and longitudes. Without them, they are just arbitrary x and y coordinates. They do not represent any specific location on Earth. A coordinate reference system essentially gives them spatial meaning. And also, I want to point out a little fun fact about projections. So projections are the reason Greenland looks really big while Africa looks really small. And essentially, they are the reverse. Like to put things into perspective, this is how big Africa is. So it can contain the whole country of the US. It can have China. It can have India, Eastern Europe, Italy, France, Spain. Like all these countries can just fit like a puzzle inside Africa, and there is still space left. That's how big Africa really is. But it doesn't seem like that on a map, and it's because of how we project Africa onto the map. And it's near the center or the equator, so it's really small. And as you move to the top, like for example Greenland, as I mentioned, and also Russia, they seem a little larger than they actually are. So, to the crux of the talk, the map. How do I actually plot the data that I have? So with GeoPandas, plotting your data is as simple as a dot plot. So we created a GeoDataframe previously, so we just take it in and just do a dot plot, right? And we get this map. But this map is really weird, right? Like it looks like my college cafeteria. It's bland, it's tasteless, and I want to add some jazz to it. And by jazz I mean interactivity. So to do that, I'm going to employ the most powerful tool a programmer has, which is Googling. So I did a little Google search because I was facing the same issue when I was trying to work with geographic data. So a simple Google search gave me a list of packages and open source libraries that I can use to create really cool looking interactive maps. So the first package I'm going to discuss about is Folium. So with Folium, you can create beautiful interactive maps. And what Folium does is it internally uses Leaflet. Leaflet is a JavaScript library that is used to create these maps, and it essentially exposes the Leaflet API, which is in JavaScript, in Python, so that you can use it to create interactive maps in Python. So let's look at that. So here we are just importing Folium, and we are creating a dot map. So we are passing like a bunch of arguments like location, so which refers to the center of the map, and we also pass in the zoom to see how much the zoom level should be, and also we pass in the tiles, for which we are going to use OpenStreetMaps because it's open, and this creates like an empty canvas that you can draw upon. So it's like it's essentially an empty canvas for doing art, and here art is the map. So what I do now is I create a Folium feature with GeoJSON. So for this, I'm going to pass my GeoDataframe, which I already created. So I'm creating a feature with my GeoDataframe, and I also mentioned the tooltip. So tooltip essentially means that when I kind of hover over this map, I can actually see the name essentially here, because I've passed the field as name, and I can pass other columns and they would be coming up as a tooltip here. So after creating this feature, I'm adding this as a child to our existing canvas, which we created right here, and after adding it, we just show it, and it's overlaid on top of each other. Right now, we just discussed how to do points, but now we are moving on to polygons. So how do we plot polygons with GeoPandas? It's again as easy as a dot plot, but in this case, since we want to do something different, we pass a column attribute. So in this column, we actually pass GDP, so that every country is actually colored by GDP here. And we also pass the CMap, which refers to the palette I want to use. I have shared a link above for all the available Matplotlib palettes that you can use. And also I set legend equals true so that I see the legend of this map. So now let's move on to how we do the same operation but interactively with Folium. So with Folium, what we do first is we create a palette which was this palette that we saw. So to do that, we use another open source package called Branca. We import the color map and we pass in the data and we pass in the steps. So I say that I want to color this with respect to the GDP and I want to go 9 steps and it's linear and this is the C map I want to go with. And after that, we define our empty canvas, which is a folium.map, and also we define our style, so which represents how we want to style our map. So it's just a function here, a lambda function. So we pass in some arguments, like for example, I pass the fill color to denote how exactly I want to fill the color of the polygons. So here at fill color, I'm passing the color map here. And also I pass the color I want the polygon to be, which is black. And I want the weight, which is the border. And also I want the opacity to be mentioned. So now we have the style, we have the empty canvas, we just plot it. Voila. So we again create a GeoJSON feature. We pass in the Geodata we pass in the tooltip, so it's name and GDP this time. So when I hover over it, you see both name and GDP. And also we pass the style function that we defined above in the previous slide. And we now add it to the empty canvas we created, which is M. And now we also add the color map so that we get this really weird looking legend, because our steps are 9. Maybe if it were less, it would have looked better. So now it's not just points and polygons and like we're done, right? So we also have some really unique plugins that Folium exposes, which are used to create really custom looking maps. And one of those maps is marker clusters. So what it does is it takes your points and clusters them into a cluster. So here is an example of the map. So here I'm importing marker cluster from Folium plugins. And then what I do is I create a location array which has a list of lat-long pairs, which I extract from the Geodata and now I create an empty canvas, I add a child, and I pass marker cluster with the list of lat-longs. So what it does is it's very similar to the slide which we saw a while back, which has just the lat-longs, but essentially it clusters these into clusters. So what we see right here is actually a clustered version of the map which we saw previously. So this is really useful when you have like a huge number of points and it doesn't really fit on the map. So at that time you just cluster them, and also when you want to create such clusters. And also we come to Heatmap. Heatmap is a really popular form of maps that is really like you really see it on televisions when they want to represent something. It's widely used in media, and with Folium, heat maps again become as easy as a heat map. You pass the list of lat-longs and you give the radius of the heat map and a bunch of arguments that you can tune, and it's as easy as this to plot. So, but with Folium, when you have a lot of data, it's really hard for Folium to actually have control over it or handle it. Even when you're doing clustering, even when you convert your points to clusters, Folium reaches its threshold really quick, and your DOM cannot literally handle a million data points. And if you try it out on Jupyter, like your whole browser crashes, and it gets really tricky. Now here's the problem. If you want to scale up, right, we cannot do it with Folium. So how do we do it? So I'm going to introduce you to the new kid in town to do exactly this, which is Kepler GL. So this is the textbook definition of Kepler GL. It's a data agnostic, high performance web-based application. But Kepler is like a really cool project which is coming from Uber. and they have actually harnessed DeckGL and GPU rendering to essentially render millions of points on the fly on your browser and perform spatial aggregations on the fly too, and all in your browser. And also Kepler GL is built with React, so you don't have to if you know React, you don't have to like re-render it every time. It just renders what's necessary, not everything. So and also installing Kepler GL is really simple with Python. You just do a pip install. If you're in a Jupyter Notebook environment, and if you are on a Jupyter Lab environment, you have to install the extension and also enable the extension in your Jupyter environment. And after you do that, you can just import Kepler GL and create a map. Now, one thing that is really cool about Kepler is that it uses configs to tune its map, and when you're using a config, that means you can customize it. So it's really super flexible. So this is config that is used in Kepler, an example one. So it has several attributes that you can tune. So for example, you have the version, which is config specific, and also we have viz states where we pass the filters. We have different layers that we are passing. They each have their own ID, the type of the data, which is a point, and also we have the label, we have the color, which here is RBG, so it doesn't make sense, but yeah, it corresponds to a color. And also we pass the columns, which is latitude, longitude. We also have altitude. So this really seems weird, right? So I'm going to break the config down to you in the next slide. So in Kepler, the UX flow is composed of 5 different layers. So these are the ones. So first you have a base map, right? A base map, which is a canvas you can build on top of. And on this base map, you can actually plot your data. So you have your data on top of the base map. After which you can do filters. So filters can be used to essentially filter your data based on a field that you have in your data, or you can do spatial filters based on spatial attributes. Like for example, you want to filter with respect to a specific city, a specific district, a specific county, and also on the filtered data, you have different interactions you can perform. For example, the tooltip that I had showed you previously, where you hover over the data and you see the attributes. That's an interaction that you perform on the data. And also there are different types of data layers that Kepler offers. So here I have shown hexagonal layers, which are used to aggregate data as hexagonal grids. So these are just clusters of hexagons you can cluster your data on. And also you have arcs that are used to represent trips. Like for example, if you want to plot data of flight movement or drones, you can use arc to show the to and from points and just draw an arc. It looks really cool on the map. And also you have point layers, so which are just points. And also you have grid. You have path, which is again used to represent a trip. And actually this is less. You also have S2, which is a space, which is like a indexing format that you can use. You also have H3 grids, which is Uber specific hexagonal indexing. You also have icons because like for example, you can add specific icons to your points and make them look a little colorful. So with Kepler, you also get a toolbar on the side like this, which gives you the power to do really amazing customizations to your map. You have filters. So here I'm doing an aggregation on fly with H3 grids, and also I'm doing color with respect to a label. And you also have timelines, which look really cool. So here is a timeline of all the trips that are happening. So the number of data points that are being plotted here are really huge, and Kepler can handle it really gracefully, and it is pretty awesome. So Kepler, Folium, we discussed 2 packages, but there's always another package when it comes to the open source ecosystem, right? People just create amazing packages after amazing packages, and the community grows on. And also sometimes these packages tend to complement each other or try to patch a gap present in another package. So let's discuss some of them. One is Bokeh, so which is again used to create interactive maps, kind of like this. So here what we do is we import Bokeh, but here the plotting gets a little tricky because the interface that we were familiar with gets really weird right now. So we actually, we have to import a tile provider. Here it's CartoDB positron, and we also give the X range, which is the range of the map which you want to see. We give it the Y range. We give it the coordinate, the CRS type, which is Mercator, which is the projection we want to use. And also we again use a similar interface to add it, and we show it, right? So this is an interface that is also awesome, but it's really hard to get used to when you're coming from plotting Folium. And also you have Plotly, which is again an amazing package. And also these packages are not just used for maps. These are generally amazing Viz packages that you can use to plot anything. So with Plotly, again, you can create a plot like this. Really cool. What you do is you do .scatter mapbox, so that you use a mapbox base map, and also you have to have a mapbox API key in your environment variables to do this. So you pass your latitude, you pass your longitude, you pass what you want to color it based on, and what you want the size based on. So here we are representing two attributes in a single map. So color represents an attribute, and the size, that's another attribute. And again, we pass the mapbox style, which is Carto positron, and also we pass the scale, which you want to plot on. And again, the zoom level. Okay, now onward to Geopattern. So Geopattern is like a project which I worked on during my free time, and if you have not cringed at it yet, it's a wordplay to rhyme with Cleopatra, Cleo and Geo, something. And Geopattern essentially is just a bunch of scratch scripts that I wrote to plot interactively with Geodataframes without leaving the comfort of Geodataframes. How do you plot these data on a map without having to do that? So with Geopandas, the plotting becomes as quick as a .folium .plot. So you don't have to define a canvas. You don't have to do, you don't have to go through the overhead that you had previously. It just becomes easier, and all the keyword arguments that I had passed become optional. So these keyword arguments are either inferred on their own, or I set a default value. So that so I focus more on getting the map out quickly than complex workflows. So if you still want to do complex workflows, we would be going to these packages, but I want to focus on the speed aspect of it. So I'm going to quickly just run through the documentation a little bit. So here, as you see, the plot with GeoJSON is just .folium.plot. And to do a circle map, you just do .folium.circle. You pass in the tooltip, the radius, the fill color, and the zoom level. It plots it automatically. And also with chloropeth maps, it becomes the data frame .folium.chloropeth. You pass the color by argument, the tooltip, the color, the zoom level, and the style that you passed as a function. You can pass as a keyword argument here, and it plots it for you. And also again, marker clusters, which becomes as easy as a single line of code. Series.folium.marker cluster. So it creates a marker cluster, and also you can perform weighted marker clusters where you can cluster these points with respect to a weight. So here the weight is value and the metric is sum. So it essentially sums up all the values and creates these clusters. And also you can do the heat. You'd like to create a heat map with the style and the zoom level, and also a similar interface is exposed for Kepler GL along with Folium. So plotting with Kepler becomes again as easy as cities.kepler.plot, and then I save it to HTML file and I open it here. And again, I get the tooltip that's exposed for me, and I can continue to change it as I want to over here. So, and also I can create simple polygons, which is again as simple as Kepler.plot. I pass the tooltip, I pass the color, which is RGB, I pass the opacity, I pass the stroke color, which I want to be black, and I want the stroke thickness to be 1, and the color to be red, which is the RGB I'm passing, and the tooltip to be continent. So I hover over it, I see continent, And again, you can come over here and change the color based on what you want, or stick to defaults. And again, you can perform chloropet map, where you mention the color field, the field you want to color it by, and the color scheme and everything, and save it. So that's how plotting becomes easier for you, because it's not in the library, but it's a wrapper around existing libraries that are already present, and I want to switch between them without having to remember all the interfaces. So that's how I allow these plots to happen. I already showed this to you in the documentation. And also, I'm focused, this package is focused on speed rather than providing support for custom intricate map flows. And again, thank you very much for listening to me, getting through all the difficulties in the tech. And yeah, I'm done.
Thank you so much, Sangarshanan. That was great. That was a really excellent talk. And unfortunately, because we had tech shenanigans, there are not going to be time for questions in the recorded bit, but thankfully we did capture all the tech shenanigans for the blooper reels, so rest easy, everyone. Please throw your questions at the venue list, and Sangarshanan will be around to continue answering them. Thank you so much.